So as we continue in our journey of building agents, so this week I've tried building a React agent. So firstly, I won't get into the theory of it. I just want to show you what it does. So let's go. Yeah, so while this runs, I'll just explain what it is doing behind the scenes. So as you can see, this is the problem it was supplied with. I think it'll be easier. Yeah, okay, all right. So this is done. So this is the problem it's been supplied with. Essentially, we're trying to solve the integrals of this equation, of this polynomial equation. And as you can see, wherever it says A, it is actually an action that is being performed. So it takes the input and then it calls a few functions as in the last time. So it parses the polynomial, it tries to get it in a JSON format, then it shows the reasoning. So it says that the input is identified as a simple polynomial, and then this expression will be passed into individual terms. And then it also identifies that this is related to calculus. So it starts preparing to integrate each term using the power rule. So that's what it's trying to break it down as a few steps. So there are 3 steps overall, and then comes the reasoning. So essentially, those again broken down into 4 to 5 more steps here. So it tries to understand what is happening and thinks it through. And then, yeah, so this is one of the parts I want to clearly show and call out. So despite, it not being able to parse it correctly, so it has raised an exception. Although it has raised an exception, so it goes into a loop of trying to reattempt solving it. So this time it tries to solve it and it still, I think, fails a couple of times. No, it works out here. And then finally it also tries to verify the symbolic integration part, and once it is verified, the final answer is displayed, and the overall number of iterations that we had to hit Gemini is approximately 9. I think 9 is a pretty good optimized number. So, and it was able to solve this equation. So let's see what it looks like. So I'm gonna open LaTeX renderer. All right, okay. Yeah, so this is how it looks. No, I think something is off here. Yeah, but anyway, the point is there may be some format difference, but it was able to get the answer right. So let me also quickly try out another problem that I had. So there are 2 problems that I was checking out. One of this is this one, and the second one is using trigonometric equations. So let me try that out. Clear. All right, I'm gonna expand this. Cool. So in this case, it was not able to figure out. Let's give it a shot one more time. Okay, so it was able to identify it this time. Awesome. Okay, so let's put this in LaTeX renderer. Awesome. So the answer of that is 13 theta minus cot theta plus c. So which is actually correct. I can provide a quick link to the answers and solutions so that it's easy for you also to go through. But yeah, overall, it's a, what do you think? I feel that it's getting better and better at solving the problem step by step. So the main point, the main idea of even trying or attempting this out is, essentially um, make the LLM think through step by step. So which is essentially called as planning. Now, as part of that, I want to show you how the system prompt looks like. Yeah, and it gets bigger and bigger as we integrate more tools into it, and also more fallbacks. So there is something interesting that I want to show you. Okay, should have copied this. Cool. So this is a prompt which will help us evaluate the system prompt that we have. So essentially, since we are trying to build something which is, as people call it, react, so which is based on reasoning and then act. So what in the backend it does is just chain of thoughts prompting. So we need to ensure that our prompt is pretty well suited for chain of thoughts prompting, and that's where this comes in. So what I'm going to do is I'll just take this prompt, this for evaluation only, and I'll hit Gemini and ChatGPT. All right, cool. And I'm gonna ask these two to evaluate my prompt. Okay, cool. So this is my prompt. Now, okay, so we got the output here from Gemini, and looks like it's pretty well done. So internal self checks check, reasoning type awareness check, fallbacks check, reasoning check, output check, tool separation works well, conversation loop perfect, instructional framing good. I can go into the details of those, but maybe I'll reserve that for some other day. Let's give it a shot in ChatGPT also. Mhm. Okay. All right. Something is off. Okay. All right. Let's see. Cool. So interesting fun fact about this while this is happening is that this is literally what we are trying to do, but of course ChatGPT does it at a much much advanced level. Hope to reach there sometime later. Awesome. Okay, so I'm super glad that none of these have come false, and the system prompt is working pretty well. And as you've seen, the results, they're also pretty verbose, and the reasoning is done accurately. It has a fallback mechanism, and hence, although it was not able to detect the right tool initially, it was able to go through the loop and was able to identify and get us the answer. That's exactly what we are looking for. We want LLM to explore all the tools that are given, see if that works out or not, give it a shot. If it doesn't work out, give it a try one or two more times, and then tell us that it doesn't work. We don't want it to hallucinate, and that is precisely how we are designing our system prompts. So this is what I majorly wanted to show for this instance. I'm gonna, so as usual, I'm yet to push my code into Git. Once that is done, I'll have the link posted in the description of this YouTube video. and I'll give you a couple of links on the LaTeX rendering, plus also the sources of where I've taken the problems from. All right, so see you in the next one. Hope I'll be building something big in the upcoming few weeks. Yeah, so stay tuned if you like to see how we evolve in writing these agents.